Okay, so for our second to last set of notes ever for the year, we're talking about dilutions. This is the other part to the molarity stuff that we talked about last week. So do you remember how to find molarity?
Mole over liters.
M equals moles over liters. What does that tell you about a solution?
Moles.
Yeah, how many moles and how many liters? But what does that mean?
Molarity.
Molarity, how much you can dissolve in it, kind of. It kind of tells you, if you think about things like, maybe like coffee, it tells you how much coffee flavor is in that water. It tells you how concentrated something is. What we're going to talk about today is how you can take something that is very concentrated and make it not so concentrated. And that's called a dilution. Just like if you would dilute your coffee, we can do the same thing with chemical solutions. We can make them less concentrated. So a dilution is making a less concentrated solution from what's called a stock solution. And a stock solution is something that you already know what its concentration is. So a solution of known concentration is sometimes called a stock solution. Anytime that I need to make a solution for a lab for you, I go back to the chemical closet, I look and see what I have, and sometimes, especially if it's an acid or a base, I have a stock solution that's very concentrated, and then I can dilute that to make something that you would need to use. We will, by the end of the notes today, be able to calculate how much of a stock solution you might want to use, how much of a diluted solution you might want to make. You might be able to calculate the concentration of the diluted solution or of the original solution. All of those are things that we can get from these kinds of problems. But to get the equation that's going to allow us to calculate those things, we have to think about what a dilution actually does. So if you think about diluting your coffee, what would you do to it maybe if you were going to dilute it?
Add milk or sugar or cream.
Add milk is probably the best answer. Sugar doesn't really dilute it, it just kind of changes its flavor. But if you were going to add milk or cream, that would definitely be diluting your coffee. What else could you add to dilute your coffee, even though people don't usually do it a lot? Water. Ice, that would be another one, because the ice would melt and then you dilute the coffee that was there. So if we go with the water example, if you wanted to dilute your coffee by adding water to it, would you change the amount of coffee that's in there? No, you just add water to it. We do chemical dilutions the same way. It doesn't change the amount of things that are dissolved. It doesn't change the amount of solute that's in there. It just adds more water. So how do we figure out the amount of solute that would be in the solution? That comes from what we did last week. Last week, we learned that molarity, or concentration, is equal to moles divided by liters. Which of those three pieces tells you the amount of solute?
The liters.
The liters is how much solution you have. So that would be the moles. So the moles of whatever you're putting in, and that's exactly what you plugged into this equation last week, tells you how much solute is in that solution. Because that's the part that's not going to change when we dilute this, we're going to take this equation, this molarity equation, and rearrange it to solve for moles. So if I wanted to solve for moles, what would I have to do? Yeah, take the liters and move them over to the other side. So we'll do that. Molarity times liters equals moles. And remember that the moles is the amount of solute, and that does not change. Just like the amount of coffee doesn't change if you're going to dilute it, you might add milk or you might add water. the amount of solute does not change when you do a dilution. So this equation that we're going to have looks very similar to some of our gas law equations. We have the before case and the after case. We have before diluting and after diluting. So before we dilute the solution, we would have molarity 1 and volume 1. And that would be moles of solute before the dilution. After the dilution, we would have a different molarity and a different volume. So molarity 2 and volume 2. If the moles before are the same as the moles after, what can I do with these two things? Set them equal to each other. Moles before equals moles after. We talked about that with the coffee. You don't change the amount of coffee that's in there, you just add something to it. You add water or you add milk. Moles before equals moles after. The moles of solute does not change during a dilution. You're just adding more water. Moles before equals moles after. So our dilution equation looks like this. M1V1 equals M2V2. Very similar to some of the gas laws that we had with the before case and the after case. So we have a couple of examples to do. Here's the first one. How would you prepare 305 milliliters of a 0.5 molar silver chloride solution from a 1.2 molar stock solution? This would be something like what I might have to do to get ready for a lab for you. If I need 305 milliliters of a 0.5 molar silver chloride solution, but all I have is a 1.2 molar stock solution, I have to figure out how much of that stock solution do I need to add, and then also how much water do I need to use. So the only tricky part to these problems is remembering that you have two parts to your answer. Because anytime you're going to make a dilution, there's two things that have to go in. How much of the original solution has to go in, and then how much water. So there's two parts to your answer. You have to remember that. Otherwise, we're pretty much just putting numbers in and doing some algebra. So you tell me, which of these numbers goes with the before case?
305.
1.2. The before case is always what you have, and what we have is the stock solution. So what do we know about the stock solution? It's 1.2 molar. Do we know how much to use? No. So we're going to be solving for V1. What do we want after we dilute it? 305 milliliters, and we want that to be 0.5 molar. So both of those are going to be the 2's. So we know the molarity of the stock solution. We need to find out how much of it to use. We know the molarity we want to make, and we know the volume that we want to make. Notice on my volume here, I went ahead and changed this to liters. There is one reason for that. The reason that I changed this to liters is because you have to use liters with the molarity equation. The one from last week, molarity equals moles over liters, you have to use liters. And sometimes I found that students get confused between last week's equation and this new equation of which one do you have to use liters and which one can you get away without using liters. So if you're not sure that you'd be able to remember that, which one has to have liters, you could just change everything to liters. It doesn't take long. Slide the decimal 3 spots. And then you know for sure that you're okay to go. However, we should maybe remember from gas laws that with these types of equations, it doesn't really matter what units you put in on one side, as long as the units on the other side match. So as long as you have the same units on both sides, technically with this equation, it doesn't matter which ones you use. Okay, so from here, plug in your numbers. Remember, you can use liters or milliliters here. It doesn't make a difference. The only thing that changes is what the units of the volume 1 will come out in. How many sig figs should we keep? 3. Multiply on the right. Divide by what's on the left. 3 sig figs. Solve for V1. Our dilution equation has told me that I need to use 0.127 liters, in other words, 127 milliliters of stock solution. There's always 2 parts to these answers because that's not the only ingredient that needs to go in. I also need to add water. How do I decide how much water to add? Subtract 127 from 305. If 305 is the total solution I want to make, 127 of that is stock. I just need to fill up the rest with water. So the 2 parts to your answer are 127 milliliters of stock solution and 178 milliliters of water. 305 minus 127 is 178. One more example to do. To prepare 1 liter of 6 molar hydrochloric acid, what volume of concentrated 12.1 molar hydrochloric acid must be used? This is something that I do all the time. In fact, I had to do this last week with the marble chip lab. You had 3 different concentrations of hydrochloric acid. You got assigned one of those 3 concentrations. I had to make all of those 3 concentrations from the stock solution that we have in the closet, which is 12.1 molar. So this is something that I use all the time. So let's see if we know where our numbers go. What's the before case? What do I have to work with? 12.1. Do I know how much to use?
No.
No. What do I need to make? 1 liter of 6 molar. I have 12.1 in the closet. I don't know how much to use. I need to make 1 liter of 6 molar hydrochloric acid. Once you've decided where your numbers go, you really just have to plug them in and solve for the one that's missing. Remember, we can use liters or milliliters with this, but our 2 sides need to match. So if we use liters, V1 comes out in liters. If we use milliliters, V1 comes out in milliliters. So plug in your numbers. Solve for the one that's missing. Multiply on the right. Divide by what's on the left. How many sig figs will we keep this time? 2. Your calculator will show you approximately 0.496. We need to round that to 2 sig figs. 0.50. 2 different ways you can write this. If you're doing liters, 0.50 liters. If you did milliliters, you would need to write 5.0 times 10 squared, scientific notation. Because how many milliliters is 0.50 liters? 3 spots over. 500, which doesn't have 2 sig figs. So if you're doing milliliters, you'd have to write it this way. Remember, 2 parts to our answer. Subtract that from a liter, so they're equal, you're right. 500 milliliters of stock solution and 500 milliliters of water. You can keep it in liters, so you could do 0.5 liters of stock solution and 0.50 liters of water.
And when we write our answers, do we have to write of 12.1 moles?
Yes, I do need to see a label, especially in this case. Well, maybe not especially here, but with the numbers being equal like this, I need to know that you know which one is which.
We just write H2O equals.
You can write H2O, you can write HCl, but there needs to be some kind of label on there so I know which piece is which. Questions? Okay, homework for tonight is found on the back of your molarity worksheet from last week. So you already have it, and it will be for a stamp tomorrow.